Hello, welcome in another important video in our Solidity course. I hope you all are doing great. So in this video, we'll be learning about modifiers in Solidity. So if you have a little bit of idea about Node.js middlewares, so modifiers concept in Solidity is somewhat similar. So let's see how it actually works. So let me quickly create new file and let me give it name modifier.sol, and first line as a first line we have to declare the version of Solidity we are going to use. So I'm okay with any version which is greater than 0.4.0 and any version which is lesser than 0.9.0. That's pretty much it. Let's quickly write first line of code. So we have to declare contract name. So in our case, contract name will be modifier1, and that's pretty much it. Let me save this. So we are getting this warning, and this is because we have to write this open source licensing, and now our code is compiled successfully. So now the situation is, let's say there is one function, let's call it as addition function. What I want is this addition function can only accessible and only owner can call this addition function. Now the question is, who is the owner of this contract? So let's say if the contract is compiled successfully, so we will select one account from this list, and whichever the account that we have selected, based on that account, this contract will get deployed. So now this contract address owner will become an owner of this contract. So what I want is only this owner can call this function, and if any other user have selected this, if any other account selected, he cannot call these functions, right? So if I try to call this add function, now this is executing, but I don't want any other person to execute this function, right? Because this function is public, so anyone can access it. But even though this is accessible, we will authorize users using modifiers. Let's imagine there is no anything like modifiers. So in general, what we will do is we will check if the message sent by sender is equal to owner. So now what is an owner? So this will be the variable that we have to declare. So let me quickly declare one variable with name address owner, and when we will update the owner address, so we will update it in constructor. So now this constructor will get called as soon as we deploy our contract. So in that time we will get message.sender, and this variable or this function will basically give us the actual owner who deployed this contract. So with this way we'll get actual address of the owner, which we will compare it with the person who called this function. Okay, so whenever we will call this function, we will get his address in this particular variable. We will compare it with the address that we have already. Okay, so let me quickly, just to check if it is working or not, so I will return 0 if he is an owner. Let's say I will return 1 if he is an owner, else I will return 0. And this should be just return, not returns. Let's save this, and our function is ready. We have to declare view because we are not changing anything in this function. Alright, so now we have one function, and we applied our logic to decide whether this function is called by owner or not. Let's see this in action. Let me delete all deployed contracts. Now our contract is deployed. Let me open this. Now if I call this function, I got this 1 because I'm using same account to call this function which I used for deploying this contract. So now the owner of this contract became this particular account holder. So now instead of this account, if I choose any other account and now I try to call this function, I will receive 0. So our logic is working completely fine, right? So now we have successfully applied the ownership on this function, and only owner can call this function, right? We can basically condition it. But now what if we have multiple functions like this? So now, like, we have addition operation, we have multiplication, we will have division, and basically we will have multiple functions multiple functions doing different operations, but they also require verification of the ownership. So now writing this same code again and again doesn't make any sense, right? So in that case, we'll have to take help of these modifiers. So if you can see here, the modifiers are used to modify behavior of the function. So basically we can write modifiers and we can pass those functions as a tag like this, and that will basically take care of checking the ownership of this function. So let me do this for you. So in order to declare new modifier, you have to write this modifier syntax. So like we write function to declare function, we have to write modifier to declare modifier, and we have to write a name of this modifier. So let's say we will write check. So now here we will check whether this function is called by owner or not. So now instead of writing this return 1, we have to write underscore and semicolon. So now this syntax basically helps us next flow after this check done. So now if he is an owner, we want to continue this function. So that is the reason why we use this syntax in order to continue our next operations. So now if this condition not satisfied, we don't want to do anything. Our modifier will automatically throw errors, right? So let me change this function a little bit. Well, as of now, I don't want to do anything inside of it. I just want this function to apply as a modifier, right? So I will do the same thing with this function as well. I don't want to do anything here. I just want to apply the ownership, right? So now we have both the functions and we applied our modifier to both of these functions. So let's declare else condition, and inside of it we will write this syntax owner can call this. So let me save this and deploy it one more time. So now this address became an owner, and if I try to call this function got executed. And if I change my address and try to deploy this, so here we received this message saying only owner can call this function. So our middleware restricted the further execution of this function. Now the benefit of using this modifiers is we can write this as many as time we can. Okay, so now let's try to pass some variables inside of this function, which we will later on pass it to this modifier. I want to pass unsigned integer, let's say a, and unsigned integer b, in order to add this variable together, a plus b, and I will add unsigned integer internally to save this answer, right? Okay, so I'll need to do the same thing with this function as well. I want to do multiplication, and I will pass these values as a parameter, right? So if I want to pass these variables which we received in actual function to this function, I can do it like this, a comma b, and I can do it like this, a comma b. And inside of this ownership function, we have to declare unsigned integer a and unsigned integer b. So now we have these two parameters in our modifier also. Let me add one more if condition inside of it, and I will check if the variable is 0, then only I want to continue, else I want to show some error message. So now this error message is different. We'll say variables cannot be 0. Cannot be 0. So let's say if I want to check variable should be greater than 0 and variable b also should be greater than 0. So in that case, I have to check same conditions here as well. So let me copy this entire thing, and if I paste it here, so this will check the condition that we wanted to check. So this ampersand is extra. Okay, so variable should be greater than 0. That is ultimate thing that we need to check. Let me quickly save this and deploy this one more time. Now if you can see here, we have two functions, and let me try to pass correct variables initially. So this function executed without giving any error. But now if I try to put 0, so you can see here we got the error saying that variable cannot be 0. So now we saw both the things. We saw how to check ownership. At the same time, we saw how to pass received parameters into our modifiers, right? So in the same way, like we have one modifier, we can declare multiple modifiers as well. And I just changed the name of this. I'm not going to change any conditions in it. To apply this modifier, we need to separate it, and we need to pass these variables again. So now this will again work the same. Let me deploy this one more time, and if I open this, so now if I try to check these conditions, 3, everything is working completely fine. And if I try to put 0, so now we can see we received this error message. So now let's see this with a diagram. Let me quickly remove this code. Okay, so now we have main function. We will call this as function A. We have modifier 1. We have modifier 2. Okay, so now the initial call that we will give from external user, and that call will receive by this function. But before executing body of this function will forward this call to modifier 1, and modifier 1 will check all the conditions, and then modifier 1 will give call to modifier 2. So now this underscore syntax that we saw here, this is basically giving a status of continue the next process. Now let's say if we call this function, first call we will receive here. Okay, instead of doing anything inside of this function, call will get forward to this function. So now this call will get forward to this modifier. So now this modifier will check all the conditions, and whenever this underscore syntax this modifier receive, it will give call to the next modifier if it is defined. Now this call received into this modifier, and then we have again, after checking all the conditions, we receive this underscore syntax, and then after that actual function will get called. So this is the entire flow of the modifiers. I hope you have understood the entire concept. Well, I think that's it for this video. Thank you very much for watching. See you in the next video.